Okay, so we just talked about atomic number, and the formal definition of that is the number of protons in the atom. So take a look at your periodic table, okay? Take a second, pull it up, pause the video if you need to. Bring up your periodic table and tell me, based on it, how many protons are in an atom of oxygen. Pause the video, give yourself a second. There are 8. Okay, if you look on your periodic table, the only number in oxygen's little box, and it's over there near the top right-hand corner, is 8, right? It's got another number in there, but it's kind of a decimal, so that must be our atomic mass, okay? So, what happens if a proton is removed from an atom of oxygen then? If I take one of those protons out, completely get rid of it, what's going to happen to the atom? Well, if it has 8 protons in it, does it still have an atomic number of 8? No, it doesn't. And the only atoms on the periodic table that have an atomic number of 8 are oxygen atoms. So if I have one less, my atomic number is now 7. And if my atomic number is 7, then what kind of atom do I have now? I have an atom of nitrogen. Okay? So if we were to take this and make it into a generalization of some sort, it would probably be something like adding or removing protons changes the identity of the element. Okay? So if you have an atom and you change the number of protons, you're not just making it heavier or lighter or something like that, or changing its charge. You're literally changing what it is. You're changing it into a completely new element, okay? So it's kind of a big deal. So, new rule, an atom will always have a 0 charge. That is what makes an atom an atom. All of our charges are balanced out. So, if an atom has 6 protons, how many electrons does it have to have? Well, we learned on that chart on the other page that protons are kind of +1 charges and electrons are -1 charges. So in order for me to balance out 6 protons, I have to have 6 electrons. Okay? How many electrons then are in an atom of nitrogen? Well, if I look at my periodic table, we know that there are 7 protons in an atom of nitrogen because its atomic number is 7. So if it has 7 protons, how many electrons is it going to have? If it's a neutral atom, it'll have 7. Okay? Now, mass number. New vocab word. Mass number of an atom is the sum of the number of protons and neutrons. If you flip back up and look at our little chart, we saw that both the protons and the neutrons were the only things that had mass for our use, I guess. And we're calling them both a +1, right? So the mass number is just adding those masses together, protons plus neutrons. Why don't we include the number of electrons in that? Because they have mass, but it's negligible mass. I would have to have way more electrons than I would ever normally have in an atom before it would even really mean something significant to the overall mass. Okay? Very, very negligible mass. So So now we're going to talk about something known as isotopes. And I did goof a little bit on these notes, and I forgot to include the definition before I referenced it right here. So I'm just going to write this in real fast. So an isotope is an atom, or when there are two different versions of an atom, essentially. So if they're the same atom, the same type, then they have the same number of protons, but they have different numbers of neutrons. Okay, so if they're the same number of protons, they are the same element. So you've got to think, okay, if I'm changing neutrons, what am I really changing? Neutrons are neutrally charged, so are you changing the charge? No. But neutrons do have mass, so you're really just changing the mass on them. So essentially, if you have different isotopes, you can use a certain symbol to kind of denote which kind of isotope you're talking about, where the bottom symbol is the atomic number and the top symbol is the mass number. Okay, so mass number is protons plus neutrons. 6, 12, 6, 13, 6, 14. But you could also call it, instead of C with a 6 and a 12, you could call it just carbon 12. Okay. So for each of these isotopes of carbon, you can calculate the number of neutrons, right? If you have the mass number and you have the atomic number, you can go through and do this calculation. I'm going to do way too much work to show this calculation. The expectation is not that you will also do this much work. But if we know that mass number equals number of protons plus number of neutrons, and the mass number is 12, the number of protons is the atomic number, or 6, then I can just find my number of neutrons by taking my mass number and subtracting the number of protons. So 12 minus 6 equals 6 neutrons total. Okay, so it's pretty easy once you get the hang of things to easily calculate the number of neutrons in a specific isotope. So if we were to do this second isotope right here, this one would be 13 minus 6 equals 7 neutrons. So it's still carbon, right? They all still have 6 protons in there. I'm not changing what it is. All I'm adding is some extra mass to the nucleus. I'm making it a little bit heavier. And this other one would be 14 minus 6, or 8. Okay, so this one right here has 6 neutrons, this one has 7 neutrons, and this one has 8 neutrons. Okay? So, coming up now, we've got this chart here. Okay, and what I want you to do is to take a look at this chart, and then I want you to pause the video and just do the chart. Okay, so look at the information it has. It has symbol, atomic mass, mass number, number of protons, number of neutrons, number of electrons. See if you can use what you remember without looking at anything else on the page to fill in this chart. You will have to use your periodic table though, right? Because you're not going to know the atomic number of chlorine off the top of your head, right? You're not going to know the protons, the neutrons, stuff like that. You can look at your periodic table, okay? That is a tool that you are 100% allowed to use. So go ahead, take a pause right now. Pause it. Do it. Pause. Cool. So, assuming you have paused the video and you have tried this chart on your own, I'm going to go through and do one column. So looking at this chlorine right here, I need to figure out its atomic number. Where do I find the atomic number of chlorine? Well, it's the number of protons, But where do I find the number of protons? Well, it's on the periodic table. If you look at your periodic table, chlorine is atomic number 17. That means it has 17 protons. And if I'm talking about an atom of chlorine, it has 0 charge, which means that number of protons is number of electrons. Bam. All of it's done already, pretty much. All I have left is my neutrons. So I've got mass number, got number of protons. I know the difference between those, just like we just did with those isotopes, is 35 minus 17, which gives me 18 neutrons. Okay? If you didn't pause the video before because you needed to see one, you should pause it, because I'm going to go through the rest really fast now. So looking at this right here, atomic number 17, only one element has atomic number 17. That's chlorine, straight from the periodic table. If it's 17, it has 17 protons. It has 17 electrons because it's neutrally charged. To find my neutrons, I have to do 37 minus 17, which is 20 total. Okay, so these two right here, what are they? What vocab word? These are isotopes of each other. They're the same element. Identical number of protons, they just have different mass numbers, different numbers of neutrons. Okay, so this next column right here, and I'll change my color. This next column right here, it gives me some different information. I've got number of electrons and number of neutrons. Well, there's not much I can do with the neutrons without finding the protons. So if I have 40 electrons, what does that tell me? Well, in a uncharged atom, I know that if I have 40 electrons, I have 40 protons. Oops, I opened the highlighter. My bad. Okay, so if I have 40 protons, then I know my atomic number is also 40, right? And if it's 40, I can look at my periodic table and say what element has an atomic number of 40, and it's zircon. And if I'm going to find my mass number, I know that it's protons plus neutrons, so 40 plus 50 gives me 90. Okay, look at my next column. It's already got zircon on there. I can't believe I was just goofing and calling that zircon. Zircon is derived from zirconium, but zirconium is the element, so apologies in advance. Zirconium is my element that I have here, and it has 40 as its atomic number because we were just looking at it. That means it has 40 protons, 40 electrons, and it's going to have mass number 92 minus protons, 40 or 52 total neutrons. Okay, and again, these ones are isotopes. I wonder if there's a trend here. Okay, last one, new color. So now I've got a mass number of 58 and 28 protons. So looking at this, if I have 28 protons, I'll just go my usual route. That means I have 28 as my atomic number. And if I have 28 as my atomic number, I have nickel in I. If I have 28 protons, I also have 28 electrons. And to find my neutrons, I have to do mass number minus protons, which is 30. Okay, and the last one is also nickel. Ooh, I'm smelling an isotope coming. I already know it's 28 because I just looked at it being 28. That means it's 28 protons, 28 electrons. It does have 32 neutrons though, so that would be 28 plus 32 or 60. Okay, so there's our chart. If you struggled with this chart, you need to find some more practice. Okay. You can Google this just about anywhere and find some practice, or get with a friend and ask them to take some info out and make some up for you, okay?